Dear students, uh, in the last two lectures we have seen the Indian standards designation of some materials, engineering materials, mechanical engineering materials that we use. Uh, Now all we have seen is about Indian standards. Now, it may so happen that you may be going and working in some multinational companies, MNCs. You may go outside. You may be dealing with big companies who will be exporting and importing things. Okay, so you must be aware of the international standards also. That means the standards which other countries use. So among the international standards, I say this standard, ASTM standard, is a well-known standard. ASTM stands for American Society for Testing Materials. ASTM, this abbreviation stands for. It could be asked in one of the quizzes what ASTM stands for. American Society for Testing Materials. Okay, and they give gray cast iron by a number. You see here, they give uh, some value like this, kilo pounds per square inch. Some of these things they follow British system. Okay, and there is another society, um, a Society of Automotive Engineers, SAE. This is also a well-known standard. SAE means Society of Automotive Engineers. And another society is like this, another standard, AISI standards. American Iron and Steel Institute standard, AISI standards. So this AISI standards and SAE standards is based on the chemical composition. Okay, for example, we can see here, for example, carbon steel has 1 or 0 in the first two digits. As the first two digits, as steel designated as 1045, SAE 1045. This indicates it's a plain carbon steel which has this second two digits give the carbon percentage like 0.45 carbon. SAE 3140 means this is a this is a nickel chromium steel with 0.4% carbon. Okay, actually you will get all these things in data books. Okay, so you see some of the things are given like this. Carbon steels are given with 1000 series. Plain carbon steels are given 10 series. See, with 1 it is starting means carbon steel. With 10 it is starting means it's plain carbon steels. With 5 it is starting means it is chromium steel. Chromium nickel molybdenum steel is 86. Chromium vanadium steel is starting with 6. Manganese steel is starting with 13. Yeah, this has also carbon. You see, this is also all these things are having carbon. They are carbon steels, but then manganese also is present to a certain extent, because of which it is designated as manganese steel. So these are about the American standards. American standards, I told you there are now 3 important standards. One is ASTM, another is SAE, and third is AISI. Okay, as of now you just know uh, the names of the institutes, and how at least these things in this table what are given, especially these plain carbon steels, or like this are designated. And then British standard, British means English, British system, how they designate is they designate the material with EN series. If you come across any material which is designated as EN, then you know that it is a British system. In each system, each country has their own standard. As India is having IS standard, British people are having EN standards. Then Americans have their own standards, SAE, ASI standards or ASTM standards, and Germans have their own standard, Japanese have their own standards, like that. Okay, see here now comparison is given between IS standard, EN standard, SAE, and ASI. A plain carbon steel 7C4 is given by EN2A or SAE 1010, or in AISI it is given as C1010, like that. Is a so just through the by this table you can know how in different countries it is called by different designations. Uh, you see some more comparisons are here in this table continuing, and see alloy steels are given in IS standard like this 40 CR4. 40 CR4. Okay, you know what is 40 is the carbon percentage divided by 100, that means 0.4 carbon, and chromium, this is should be divided by 4, so it is 1% chromium. Okay, whereas British standard is EN18, SAE standard is SAE 5135, and ASI also. See now these two are much they have combined their designations, so they use the same values, SAE and ASI. Earlier it was given by SAE standard, nowadays no, all are shifted to ASI. Now ASI gives the standards in the America. Okay, okay, next we come to this topic, standardization. Standardization, you may be asked to define standardization and name four specific standards or standard codes of practice. Okay, like that there is one question asked. Okay, you see what is standardization? You see nowadays all these modern systems nowadays what we are using, they are becoming more and more complex. See, they are having various a large number of mechanical parts, they are having many controls, and computer systems, communication systems, these are all interconnected in a complex system. uh, Such a complex system can have many sources of errors. So the main purpose of standardization is to establish mandatory or obligatory or compulsory norms for design and production of machine component. At design stage also and production stage also, certain standards everybody should follow, whether you are in a country like India, or in a country like America or Europe or any other country, even African countries, South American countries, Australian countries, or rest of Asia countries, anywhere. See, if you are there, if you follow standardization, so if you supply some material, some machine, some motorcycle to a foreign country, you see, and if some of the parts are to be changed or something, they'll be able to find in their own market some standard part with which they can replace it. Okay, so these are mandatory or obligatory. That means these are compulsory norms which everybody should follow, and these are for design and production of the machine components, so as to reduce the variation in their type. That means variation means what? There should be some, see, it should be that, if you go to a market, go to a hardware shop, you see, you will find a nut of 10 10 number. 10 number means what? You see, it's in a 10 number, 10 mm spanner, pana pana में वो बैठता है 10 mm. Okay, or the what we should say, uh, you see, you take any nut in your house, and you see through which spanners have different numbers on them. You see, it may have 8, 9, 10, 11. it may have numbers like 8, 9, 10, 11, 12, 14, 15, 16, 18, 20, like that. You may have various types of various spanners. On the spanner number will be written, you see. Okay, they see a mechanical engineer should know all these finer details. Spanners have different numbers on that, so they can open those things which are written on it. Okay. uh, the, okay, so you see, you can find a, a 10 number. Okay, that means a 10 mm is the um, distance between the two straight faces, parallel faces of the spanner. Okay, and see, you cannot find a 10.2, 10.3, 10.5, like that. You cannot find. You see, if you are going to make all those things, oh, the variation will be so much, then it will be very difficult for the stockists to keep, for the shop people to keep, for people to make. So the spanners will be either 10, 11, 12, 13, 14, 15, 16, 18, 20, like that only you will find. Okay. So to reduce the variation in their type and grades and to active quality characteristics in raw materials. You see, in raw materials, semi-finished goods and finished goods. You see, in the company, if you talk about materials, the materials can be in three states. It can be a raw material. That means just material that is come out from the market. Okay, semi-finished goods. You see, once the raw materials are taken and you have worked in the first machine, second machine, like that, in the middle between the machines, what material is there, you can call it as semi-finished goods. When all the processing is finished, you may get something called as finished goods. So the goods can be in the form of raw materials, in the form of semi-finished goods, and in the form of uh, finished goods. Okay, and these things, their grades and their quality characteristics and their variations, all this, to have a control over that, we use standardization. See, and there is something called as code also. One is standard, another is code. The code is defined as a set of specifications or procedure for design, analysis, test, design, come out, it should be there, analysis, testing and manufacturing of a system, component or product to achieve uniformity, quality, interchangeability and safety, and to put reasonable limit on variety in established and variety, and on limit on the variety is established by standardization. See, I will give you a better definition than this. You see, you can write and keep this definition. You see, a standard is a set of specifications for parts, materials, or processes. That's all, the definition for standard. Again, I'm repeating, a standard is a set of specifications for parts, materials, or processes. And the definition of code definition is, it is a set of specifications for the analysis, design, manufacture, testing, and erection of the product. I'm repeating again, the definition of code is, it is a set of specifications for analysis, design, manufacture, testing, and erection of the product. So this standardization, is because, to bring some, uniformity in the, in the uniformity and um, and to bring quality, to permit interchangeability. Interchangeability means what? See, if you say, if your car tire is removed, you see, car tire has four nuts there, four nut bolts. Okay, you see, if you take one nut from one thing, it can fit anywhere on the four. See, it is not that you have to put a number on that 1, 2, 3, 4, and one match for one only, two should match for two only. See, that will happen only if it is made by a man or something. If a proper man manually is making furniture, he will write numbers and keep one should go in one, two should go in two, like that. Okay, but if you are making in the companies, they see that for interchangeability, these standards are used, and its standards are used for safety purposes also. Okay, and also a reasonable limit should be there in the variety should not be so much, that it is becoming a burden for people. Okay, so that is why this standardization is practiced. Okay, now let us see standards used in mechanical engineering. You see different standards for different components. You see from standards for sizes and shapes of components like nuts and bolts. Nuts and bolts, you need, there, otherwise there will be a lot of variety of nuts bolts. So you want to limit the number to reasonable amount. So you have to use standardization. Then bearings, different types of bearings you can find out, different that's why you need standardization. See, because bearings are all not made by one company or one person. If different companies are making, and you see, then they see the variation will be so much that you'll find difficult. One part, one bearing is to be changed in a machine, then it will be very difficult unless you follow standardization. Then keys, gears, chains, belts, etc. Some certain things. Okay, then standards for products like electric motors, engines, gearboxes, pressure vessels, etc. You see, all these things also follow standards. There are Indian standards for each and everything. Okay, if Bureau of Indian Standards releases standards for each and everything. You see, if you say take something like electric motor, for electric motors, how the motor should be, with what speed it should be rotating, what should be the length, what should be the breadth, or what HP it should be, or what kilowatts it should be, and how the engines should be. Okay, how the gearboxes should be, of what sizes, how much variation, all these standards you'll find. For pressure vessels you'll find everything, you will find. Okay, unless there are standards, you cannot ensure the standards. Okay, see, once the standards are fixed, framed, we can send inspectors on to check whether their pressure vessels they are using in their company, these pressure vessels will have pressure inside, like it can be because of some steam or vapors of some other gases, and sometimes the blasts will take place. So in order to avoid accidents and the loss of life, the inspectors will go and check these pressure vessels. How will they check if there are no standards? You see, if standards are there, they will check whether it is matching the standards or not. Then standards for fits, tolerances, surface finish grades of components. Then standards for conventional representation of components, and the drawings. You see, now in the drawings also you are learning that this should be drawn like this only, this should be drawn like this only. That is a standard. Engineering drawing, it's a standard. Who told that a center line should be a chain type, one big dash, one small dash, big dash, small dash? How a cutting plane line should be, how an outline should be, how the projection line should be, how a hidden line should be? Who told? It is the standards which are telling. Okay, so for all those things there should be standard. If a map is drawn, how a map should be drawn, India map is drawn, how what color rivers should be represented, or how mountains should be represented, how the state boundaries should be represented. Who is telling? There are standards for each and everything. You see, there are thousands and thousands, maybe lakhs of standards also are available in Indian standards, in different fields, not only engineering fields, different fields you will find this standard. You will find the standards in different fields. You see, even if you take a sewing machine, on the sewing machine also you will find ISA mark. You know that an electric motor you will find an ISA mark. You know, you in electric fans, you know, even cable electrical wires. Everything is standard. You see, doors, latches, you know, everything. There is a shaft, there is a nut, bolt. There is on cycles, on motorcycles, on cars, on on everything that you see. There will be standard. Each part is made to some standard. You see, if the things are not made to standard, then you know to enforce the standard it will be difficult. Unless there are rules, how will we say who is going against the rules? The rules should be there. Rules are there. You see, if rules are there, we'll be able to enforce rules. How the policeman will, police. You know, for police, should be told, you know, this is permitted, this is not permitted. So that is the rule. This is permitted, this is not permitted. Three people should not go on the motorcycle. This is a rule made by the government, and that is enforced by the traffic police. You see, the rules are standards. Okay, for materials also, for machines also, for every component, there is a rule. If we are making a dam, if we are building a dam, there are certain rules. You see, if you are making a road, it will be standard rules. You know, you may have seen after road is made, some people will come and say take measurements and do survey and all those things before releasing the bills for that making of the road to that contractor, whether he has made according to the rules or not. Somebody should test and verify. So if it is made, see, roads are made to standards. Buildings are built for standards. Even our buildings in which we are staying, these are made to standard. How windows should be, how doors should be, how steps should be, how much height each step should be, how width should be. You see, it is not that only one dimension will be there. You know, in the standards for each thing, they will give a certain variation of standards. Within that, you should be, it should follow. It is also for safety purposes also. For safety, if your buildings are checked, what for? You see, firing extinguishers, these are all according to standards. Okay, so let us see now the advantages of standardization. Some of the advantages of standardization are as follows. Interchangeability. I told you, you know if suppose you are driving a cycle, and in your cycle when you are driving, one of the nuts, it became loose and fell off somewhere on the road, and you came home and saw that this the nut is missing. You see, if standardization is there, you will go and find in the shop, I want 10 number nut or 12 number nut, and you will buy it and come and put it. You may get in 1 or 2 rupees there. See, if standardization is not there, what will happen? You have to go to the person who makes the nuts, and you have to say, see, this is the place where it is lost. Its diameter is so much. The thread's outer diameter is so much. Inner diameter is so much. Pitch is so much. You please make one nut and give. And he will say, okay, you come after 2 days, and by that time I will keep it ready, and he will make it and keep. And you may have to shell out something 500,000 rupees for that nuts. You see. See, if standardization is not there, how will you attend to the interchangeability? You should be able to use things like that. 10 number anywhere you put, whether you use it on cycle or motorcycle or in the house for the door or somewhere. You see, if 10 number is 10 number, you can use it anywhere. See, this is interchangeability. That means whether you use here or you change and use somewhere else, it is the same. Then better quality, products quality will improve, reliability will improve, and a longer service life you will get. You see, for these purposes, standardization is used. And mass production of components. You see, if you have standards, you will produce in mass means what? Oh, plenty, thousands and thousands and things. You see, now if somebody is making a Maruti car, this is Maruti Suzuki car. Okay, all Maruti Suzuki cars will be like. You see, that is being produced in Maruti company through mass production. If you take Hero Honda motorcycle, all Hero Honda models, motorcycles of one model will be similar. Why? Because mass production is done. Okay, mass production becomes possible only through standardization. Then sometime it ensures the safety. See, for safety purposes also. I was telling you about the houses checking, the roads checking, the dams building and all those things. You see, even motorcycles, when you're driving, if it is not according to standard, you may go and dash against somebody, because something became loose, some part came when you are at high speed. See, the safety, for safety purposes also standards are useful. The easy and quick replacement of components is possible. Easy and quick replacement. Then less time and effort are required to manufacture. If you are following some standardization, so producing will take less time and also it will take less effort. Okay, and then various sizes and grades, a reduction in the sizes. As I told you, you will find 10 number nut and 11 number nut, not 10.5 or 10.6, 10.7 nuts. Okay, see, that means what you are limiting the variations means variation means what, different types, different what we should say, variations means, how many varieties are there, how many varieties are there. Okay, so that we should limit to a reasonable level. Okay, so we'll stop here today. Thank you.